Now we'll proceed with the next speaker. Let me introduce first our next speaker. Our speaker has earned his degree in mechanical engineering from Temasek Polytechnic, Singapore, and a degree in logistics, materials, and supply chain management from Northumbria University, England. He has quite a number of work experiences related to 3D printing. He has worked as an application engineer manager under Creates 3D Pte. Limited, a Singapore-based 3D printing solutions provider. He has also worked as a senior application engineer for the Greater China region with Stratasys, an American manufacturer of 3D printers for rapid prototyping and direct digital manufacturing. Under Flowserve Corporation, a supplier of industrial and environmental machineries such as pumps and valves, he held the position of Senior Additive Manufacturing Process Engineer. Currently, he holds an application engineer under the company Markforged, a manufacturer of industrial 3D printers, print systems, and software. To speak or to share with us on the topic identifying opportunities for additive manufacturing, the AM application specialist for Markforged, please help me welcome Engineer Lee Chen.
Thank you so much for the introduction. I didn't expect that so powerful the internet is that all my profile can see online. Anyway, my name is Lee Chen. I was based in Singapore as well and working in Markforged right now as an application engineer. So just a little bit briefing clarification about my role that I'm not an application engineer working for software application in your mobile, because recently I received a lot of headhunter to ask me if I want to join to a software company, but my role is mainly for spotlight all the possibility in our prospect or our customer on using and adopting additive manufacturing. So yeah, so this is my topic, is working the line for Markforged. Alright, this is my agenda, and talk about the first one, the key takeaway on working the line. Usually we would like to ask our customer or someone in the factory to let us join or view their production flow to see if there's any chance for us to see the possibility of using additive manufacturing. So basically we'll talk about from the three aspects. Next. Alright, so the challenge is the assumption about 3D printing, because we know that previously or back to like from the first presenter, we mentioned that start from 1982 we have a lot of we know there's a 3D printing happen, and right now it's already past to 30 years plus. But still a lot of people have the assumption of 3D printing is only used for rapid prototyping. But right now we are trying to change the way to tell people it's not just used for rapid prototyping, but also can use in some manufacturing process or even used for a used part. Then we will choose the right part for benchmark, and also help the customer to calculate the ROI, return of investment of having a printer in-house versus right now the conventional manufacturing, how much saving you can have. So why Markforged choosing manufacturing as the way to go, the application to go, rather than comparing with other 3D printing company? The differences is because in manufacturing we're actually looking at three aspects: strong part, the faster lead time, and also the lower cost. And for faster lead time and lower cost is a sweet spot for additive manufacturing, and for unique strengths for Markforged is the strong part we can build. That is because from this graph you can see most of the material actually is fall under those category and the lower category, which is the plastic category. But we are printing composite, continuous fiber, we can reinforce in our printing part, so we can reach to equivalent strengths like metal part, and that is where we try to move to manufacturing rather than just rapid prototype. So here is an example that we see in our customer side. They print end of robot gripper by Markforged print. And also from the CNC carousel, you can see some customized tooling. I will share that in the next few slides. And also this is printed by our MIRDC-AMCen. We actually have the MIRDC-AMCen system here. So in the future, if you want to try the metal printing, then you can talk to our partner here, OmniFab, and also AMCen. Then this is also a gripper that printed by stainless steel from our MIRDC-AMCen system. So Markforged actually lives in manufacturing already in North America, in some countries in APAC, also Europe as well. So it could be in some highly automated environment like this like this one. This is automated assembly production line in automotive factory, or some simple machine shop you can see somewhere in some local factories here, or even like foundries. And this is the sheet metal bending or sheet metal cutting workshop. All these areas can have potential, even like the CNC shops. All these areas have potential to use or apply additive manufacturing to replace or implement some of the process. So this, our advantage is the strength, toughness, and also the printer generate a very fast ROI because we can print in a faster manner compared with some of the part we can print in a faster manner compared with our conventional manufacturing, and also we can accelerate the tool development. That is the most important. One thing we like to ask our customer or prospect, especially in the very big factories, to try to find a lot of experts. Because a lot of time we will talk to like managers, maybe they are purchasing, procurement manager, or even like CEO of the factory, but actually they already have some expert in the factories, in the manufacturing world that can help to identify a lot of chance or they feel what is a pain point is to point this out, and so that we will see that maybe it's beneficial for 3D printing to replace some of the process. So it could be from engineering team or the line production supervision, like how to optimize the line efficiency, production line efficiency. Maintenance, if you have some obsolete parts, and also or like QA/QC process after everything before packaging. You need to have the quality assurance, right? Assurance department usually they will have some problem or pain point that different from others. So there are three lenses that we can try to spotlight and what are the potential problems. So I would say problem that what are the potential improvement that can be done by additive manufacturing. So go through one by one. First thing is the pain point, the current thing they feel very pain about it. So we talk about the cost because everyone in the factory were running for earning money. So saving the cost is definitely something that everyone will pay more attention about, right? So we'll talk about cost. The cost is highly measured by $/cent, but actually cost can have other elements can be measured. It could be the labor cost, the time cost, the productivity cost, and also the capital cost for investing a new solution equipment, right? So all this considered together, actually costs also have some hidden additional costs like unplanned downtime for your whole production line, and line changeover calibration, because after change from one product to another product, the whole production line need to change and calibrate, and the it's very time consuming process. Then the third one is the aftermarket. If you want to do some replacement or you want to do some upgrade by yourself for your machine or for your production line, that could be another chance to involve very high costs. And the last one is the carbon engineering. I will talk about that in detail later. So unplanned downtime, this is a picture that, although it's not very commonly happen, but once it happens, it will give you a very dramatic expense on recover those accidents happen, right? So an example, like 10 years before in North America, there's one hurricane or tornado destroyed Amazon's one of the factory in North America. And what they did is they tried to apply the additive manufacturing to recover their operation, and the starting line is about 2 years. By applying additive manufacturing, they try to shorten this recovery time into 6 months. And imagine for a factory, you save 1 year and a half the time and how much value or revenue you can create within this additional 1.5 years. The second thing is the unplanned downtime for immigration, or sometimes you have to do the changeover. So imagine for this picture, inside we have very fully automated production line, and what if there's one of a very small particular parts is damaged or already broken, and you don't have the spare part in your stock? You have to rely on the OEM to pass the part to you. Maybe the OEM is back to Sweden or Italy or even North America. Then you have to wait for the lead time like a few weeks. There is a very hassle time. Then you have to stop the whole production line and just wait for a tiny part to be replaced. But now if you have a 3D printer in-house, you can just print this out and replace it right away. Then line changeover calibration. Even though you don't have a problem on your production line, but from product A to product B, you do a lot of changes and probably need to change a lot of jigs and fixtures or some special tooling or customize your tooling by yourself. Then a lot of recalibration need to be done, and those calibration tools are sometimes could be customized as well. So a highly customized thing is very essential for this process, and it could maybe by this moment in Philippines you have to outsource to some other people to help you to do those tools. But right now, if you have a printer can help you by yourself, then it will just drive the whole thing very fast. The aftermarket upgrades is very commonly happening all over the world, and especially we are talking about like old machines, like 30 years old, more than 10 years old already. Then they don't have, the OEM never support the spare parts. Then you have to do some spare parts by yourself. If you go outside to just machining one part, it will be very costly. But right now, if you have a 3D printer, again, you can save your time and save your cost. So just now I talk about the cardboard engineering, right? So is it made of tape, putty, or zip type originally? So cardboard engineering is actually what we try to say is actually a lot of emergency maintenance or repairing in the actual operation in the engineers or operators' daily life. So a lot of time actually on the production area, they will see there's a problem, so they try to solve it by themselves. But they don't have a lot of resource or budget to buy from outside, so they just try to do something like that. So it's like a temporary solution. They can solve the problem by maybe a week or a month, but it's still a very high hidden risk that in the future it could create a bigger problem, like destroy the whole machine because of this one is not stable. And they never report this. So that's another thing to elaborate. Alright, so the question to ask yourself, actually yourself means all the people that using the conventional manufacturing in the production floor is there's a few questions. What are the areas is costing you the most, whether there's a chance for using additive manufacturing? What are your biggest cause of loss, waste, or unnecessary manufacturing costs? And is there a way of using or replacing by additive manufacturing? What does break or replace? What are the parts very often to be broken or need to be replaced by because of the wear and tear? Is there a chance by using additive manufacturing to replace that? And how much does it cost, so that we can from there to know if it is valuable of using additive manufacturing or not? And then what are the source of unplanned downtime? Let's just put a scenario that what if this kind of thing happen, the unplanned downtime happen, what are the resources you can faster your recovery? And if there's another solution like additive manufacturing can help you. And then what are the parts that absolutely need to be stay running? Those parts definitely cannot be wear, and we have to replace very fast. And then do you have any area that where things are fixed or with duct tape or cardboard, like just now the very classic example, can be replaced as well? And then do you have any areas that where things are fixed? Do those cause issues for updating lines, like some customized updating? Right. So, not just ourselves, but go for really industrial. Try to ask those people like plant managers, manufacturing supervisor, and a production supervisor, maintenance supervisor, and even machine operator. They will give you like different point of view about what they feel about manufacturing pain point. Then we start to talk like AMCen maybe work with some customer from from industry. That we can talk about what is a possibility of using additive manufacturing, because I think they more consider about cost effective, and we more consider about how to innovate them to adopt this new technology. Alright, so easily identifiable manufacturing application. We have another angle to see is based on the application, not just on the cost. So the application setup, machine setup, fixturing and positioning tooling, these are the existing well known for, at least for Markforged to be replaced, and those are the things that just now I mentioned. And also in the future, how to optimize the production line is another topic that we can see, and we can help customers to calculate the ROI for them. So tooling and work holding, classic example like soft jaws. And you can see this is a pair of soft jaws that we do on our machining or our drilling process. So in the first place, we have to we have to machining this soft jaw and then machining this part. Then after that, we do drilling. But right now, we can just use onyx, some fiber material, have the equivalent performance like metal to hold this part. So actually this soft jaw is just printed by itself. It's just used like overnight time, you can print this out, then grip this part. So your CNC machine, the more expensive equipment, is used for more valuable operation rather than printing, rather than merely those tools. Alright, so, and also why we print your work holding is because a property of the material is a non-marine part. We won't scratch the metal piece, the actual work piece we want to do, because we are composite, so we are kind of like softer than metal. The second thing is can reduce your work and the polish time. Once you print, later you can go to the exhibition room there to see our printed parts. Is the surface finishing already great enough for those kind of application? And then lastly, you can improve your product quality. Robot arm tooling, I'm not sure is this very popular in Philippines, but right now actually a lot of factories try to adopt this automation process, and they need to use robot arm. And once we talk about robot arm, a lot of modular design or customized design have been involved. So this is where us and to help them to make it better. So example for this is from customer called Dixon Valve in North America, and those black color gripper, 3 as one set, is printed by Markforged onyx glass fiber. The weight of this one is only like like 2-digit gram. And imagine if this kind of volume, if you print in metal, it will be very heavy. So we all know that actually for robot arm, you have a certain capacity of holding the weight. So if the end of arm, the gripper is very heavy, we only can hold like a lighter goods. But right now, if our gripper is lighter, we can grab or hold even heavier goods. And this is another way of using this gripper is using vacuum suction. So because additive manufacturing can print some lattice structure or hollow structure inside, so we can actually hide those vacuum tubes, or just use the, we print a vacuum channel to use those vacuum suction gripper. So the black color is actually what we print, and the inside is all the hollow channel inside. And how many potential Markforged applications you can see? Just for example here, you can see all the, in fact the answer will be all the brackets, the grippers, even below the jigs and fixtures, all these things can be done by Markforged printers. The fixturing for quality control in QC, this is a ducting made from an aerospace company, And right now, this process is actually in the QA/QC role. They have to place this part and the CMM measuring tool going to measure this part from top to bottom. And because of the geometry is not, you can just lie down on the station, workstation, that you can just measure it. You have to use some special fixture to hold this part in parallel with the horizontal surface. So in that case, the black color is what we print. And we help the customer to hold this part correctly. And this is a step one of measuring the dimension accuracy. The second one is we need to flip it over, and this black color again is what we print for this process. And this process is actually on top. There's a laser marking machine. It will mark some label on top of that, and then also some simple base fixture for laser marking machine inside. We can do some customization for different products. And customized tooling, this is a bar puller. It's in the carousel of the CNC machine. And because of different size you have to grab by using this tool, we can customize the whole set of different bar pullers. And previously, this is the original design from the OEM, the machine manufacturer. It's very heavy. And you have to manually control the width, the distance between these two gripper. But right now, because of right now we have 3D printer, you just design it and have the different width, customize it for different operation. Plus, it's lighter and it's cheaper. A common material in the tooling and fixture, we are talking about aluminum, tool steel, stainless steel, carbide. Then plastic, we're talking about those. UHMW is a composite, and During, nylon, Teflon. All these materials have potential to replace into additive manufacturing material. So guess what? How we replace this process is in Toyota. They do inspection and do the assemble for the engine block. So actually here, the color tells us this is made by composite. Then we can just replace it. As simple as that. And then here is where we use the UHMW, the composite material for non-marine holders. And it is again customized, and most of the time we do in CNC milling for this. Yeah, and I will go through detail for this because I think my time is over. So again, this is a jigsaw fixture. So lastly, I just want to, sorry, I kind of finished it, but lastly, I just want to share the story about a true story about happening, the conversation between in the industry, 3D printing industry, about my title, application engineer, because I seek for this role for like 7 years. Although different companies, but all along working for an application engineer, this role. We realized that when I'm talking to the people in the industry, we realized that 3D printing industry is kind of unique industry that require application engineer in this role. Is because we have to educate customer to tell them how to use this printer and how to find the solution. That's why we have this role like me to call application engineer to tell you this is the application you should go for. But in the future, I wish that in Philippines, very thank you for the initiative, for have this AM center, and also our partner OmniFab here. We can create a new era for, hopefully we can create a new era for our younger generation, that in the future everyone, we have some expert in Philippines that can identify by themselves in each of the factory that where we can use additive manufacturing. It seems, hopefully eventually it will be same like currently like CNC machine. There's some expert who can identify where to do CNC and how to do the CNC machining better, so that it can. So that my job, my title can be eliminated. Then, yeah. So hopefully that will be the idea for additive manufacturing, that everyone knows how to do that. All right. That's all for myself. Thank you.